In this lecture, we will discuss about functional dependencies. We consider a relation R where there are two attributes alpha and beta. Let's assume that alpha represents roll number of a student and beta represents the student name. So if we have a functional dependency, which is written as alpha determines beta. Now basically in mathematics we say that if we have the value of alpha, you will be able to compute the value of beta. But in terms of functional dependency, it means that when you have the value of alpha, you will be able to search the value of beta. So given the value of alpha, you will be able to uniquely identify the value of beta. Let's have a look at this particular relation. We have alpha and we have beta. If you have a roll number of a student, you will be able to uniquely identify the name of the student. So roll number 1 refers to student A, roll number 2 student B, roll number 3 student C, and roll number 4 student D. Now, if I make a small change to this particular tuple, let's say I say that roll number 1, I make a small change. Is this tuple valid? Can I say roll number 1 refers to student A and roll number 1 also refers to student B? This is not possible, right? So this thing is not possible. When we talk in terms of mathematical concepts, if I have something like f of x determines y. Now I can say that when 1 is substituted for x, it will give me the value A. Now I will write two more statements. That is 1 gives me B and 2 gives me A. Now can I try and identify which statements are correct over here and which statements are wrong. So if I assume that this statement is correct at the initial phase, then in that case this statement will be true. This statement will never be true, right? Because if on substitution of 1 if it gives you A, then always on substitution of 1 it should always give you B. But there are chances that on substitution of value 2 it will give you the same answer. So in this case this is not a valid statement. So basically, given a value of alpha, it will help you uniquely identify the value of beta. Now we'll look at the formal definition of functional dependency. We assume that alpha is a subset of a relation R and beta is also a subset of a relation R, where we have a relation R where alpha is a set of attributes and beta is also a set of attributes. So we refer to the first tuple as T1 and the second tuple as T2. Now, mathematically, how do we define a functional dependency? So if we have a functional dependency which says alpha functionally determines beta, then if T1 of alpha is equals to T2 of alpha, it means that if there is 1 over here and 1 over here, then it should give you the same value on the other side. That means if roll number 1 is in the first tuple and roll number 1 is in the first tuple, that means it should give you the same name. So if T1 of alpha is equals to T2 of alpha, then mathematically we can define the functional dependency as T1 of beta will be equals to T2 of beta. So it means that if you have the value 1 over here and value 1 over here, then it means that the beta value also should be the same. Beta value can never be the same. It means that roll number 1 cannot be given to any other student. So this is not allowed. Now, when we talk about functional dependency, your functional dependency can be decomposed into two types, which is called as trivial and non-trivial. So basically in trivial FDs, what it means that if you have, it means you have the roll number of the student and the name of the student. So basically it means that you know the roll number of the student. So basically trivial. So if you know the roll number and if you know the name, if you know the roll number and know the name, that means you know the roll number of the student. So basically it means that beta is a subset of alpha. So now if I consider this as my alpha and this as my beta, then can I say that beta is a subset of alpha? So this functional, so this FD holds in this case. Whereas what do you mean by non-trivial FDs? It means that if you know the roll number of the student and the name of the student, you will be able to determine some additional information. So maybe I can say you can identify the branch of the student and the address of the student. So basically in this case, beta is not a subset of alpha. In the next session, we will see problems on non-trivial FDs.